I'm Eileen Haffner. I'm a senior physics and math major, and for my senior thesis project I made a pulse jet engine. Pretty much how this works is it originally you need a spark plug, air intake, and a propane was the fuel we used. Pretty much we flow in fuel and air mixture. We use a spark plug to ignite a small explosion. Once that it has exploded, hot gas is going to rush out the exhaust pipe. And because it's rushing out so fast, it's going to create the internal pressure is going to drop below atmospheric pressure. So then it's going to create a vacuum, and it's going to suck in more fuel and more air and actually raise the internal pressure so great that it will start another explosion by itself without the use of the spark plug. And it'll just keep repeating this process and make small explosions in a pulsating manner. And pretty much there's about 100 small explosions per second. And after it gets started up, you can actually remove the air intake and shut the spark plug off, and it'll run completely statically without any external adjustments, which is really neat. Pretty much this type of engine was originally designed in 1928 by a German engineer. They were utilized heavily in World War II for what's known as a buzz bomb. Pretty much they were pilotless aircrafts that had a bomb attached to them, and they would just fire them, and eventually the propane would cut off and the aircraft would just drop, and on impact it would explode. And so they actually fired about 13,000 of these at London during World War II. But since then, they haven't really been utilized much. They have a really great weight to thrust ratio, but they have a really, really poor fuel consumption rate. They use a lot of fuel. So because of that, and also they're extremely loud because of the pulsating explosions, that they can't actually be utilized in commercial or for military purposes. But today they're used mainly for model airplanes and stuff. But pretty much we got really good results off of my engine. We originally hypothesized we get about 1 Newton. We actually ended up getting 4.2 Newtons of force coming out the exhaust, which was a lot better than what we thought, so we were really pleased with it. However, it did actually end up using, we ran it for a good 15-20 minutes. It ended up using about a pound of propane just to run for that short amount of time. But, yeah.